Let us see what's known as reciprocal equation. Here a polynomial equation is given. Let alpha be a root of this equation. Alpha cannot be 0 because here there is a number, non-zero number. Then if alpha is 0, all these terms will become 0 and finally you will get a 2 is equal to 0. So alpha cannot be 0. Since alpha is the root of this equation, wherever x is there, you substitute alpha. Then it will be satisfied, so you will get 0. Then in this polynomial equation, for x you write 1 by alpha on the left hand side. Don't equate it to 0. For alpha 1 by alpha, for x 1 by alpha, for x substitute 1 by alpha. Then LCM of this denominator is alpha raised to 6. Here alpha raised to 6. In the denominator there is alpha raised to 6. You divide this alpha raised to 6 by alpha raised to 6. So you will get a 1, 2 into 1, 2. Similarly, you complete this. Then in the numerator you will get this expression. But you see this and this same, 2 alpha raised to 6, only the order here from left to right, here it is right to left, same. See, 2 alpha raised to 6, 2 alpha raised to 6, minus 3 alpha raised to 5, minus 3 alpha raised to 5, root 2 alpha raised to 4, 7 alpha raised to 6, root 2 alpha square minus 3 alpha plus 2. So that is 0. So for this we can write 0 divided by alpha raised to 6. 0 divided by anything is 0. That means if alpha is a solution or a root of this equation, 1 by alpha is also a root of this equation. So it's called a reciprocal equation. If alpha is a solution or root, 1 by alpha also will satisfy this equation. So such equations are called reciprocal equations. Now here you can see note, see 2, 2, minus 3, minus 3, root 2, then 7. That's why when alpha is a solution, 1 by alpha is also a solution. Reciprocal equations are of two types. This is the first type, type 1. So here you can see coefficients from the beginning are equal to the coefficients from the end. 2, 2, minus 3, minus 3, root 2, then 7. So in this polynomial, wherever x is there, you write 1 by x. Wherever x is there, you replace it by 1 by x. Then this is a polynomial in 1 by x, of 1 by x. Then multiply it by x raised to 6. This polynomial completely you multiply by x raised to 6. So when here you multiply by x raised to 6, this x raised to 6 will get cancelled. So it will be 2. Here when you multiply this with x raised to 6, down it is x raised to 5, so it will become x. Similarly, you complete this multiplication, all the terms by x raised to 6. Now you can see these two are same. Here 2x raised to 6, 2x raised to 6 minus 3x raised to 5. So this and this are same. Here it is from this side to that side. Here same thing from that side to this side. These two are same. That means p of x is x raised to 6 p of 1 by x. So polynomial in 1 by x. So this is what is known as type 1 polynomial. In x is x raised to n. Generally here it is, instead of x raised to 6, x raised to n. So this is type 1. Now you see this polynomial, coefficients from the beginning is equal to the coefficient from the end, but it is of the opposite sign, plus 6 minus 6. Here same sign, plus 2 plus 2, minus 3 minus 3, but here equal but opposite sign, 6 minus 6, minus 41 but plus 41, plus 97 minus 97. So now here if you replace this x by 1 by x, and that expression if you multiply by x raised to 5, the same way you will get here p of x is equal to minus x raised to 5 p of 1 by x. So in this case polynomial in x is minus x raised to n p of 1 by x. So this is what is known as type 2. This is a odd degree type 2 polynomial equations. See, plus 6 plus 6 plus 1 plus 1 minus 43 minus 43. Here sum of the coefficients of odd powers will be equal to the sum of the coefficients of even powers. So x is equal to minus 1 is the root for this equation. So odd degree type 1 equation minus 1 will be a root. This is a odd degree type 2. Then here sum of the coefficients will be 0. See, plus 6 minus 6. So 0. Cancel each other. Then minus 41 plus 41 plus 97 minus 97. So when you add the coefficients, it will be 0. So x is equal to 1 is a root. This is a type 2 even degree polynomial equation. Here plus 6 minus 6, minus 35 plus 35, plus 56 minus 56. So here middle term, coefficient of the middle term should be 0. Then x is equal to 1 and x is equal to minus 1 will be a root. So even degree type 2 equation, middle term should be 0. Then x is equal to plus 1 and x is equal to minus 1. Both are the roots. Then reciprocal equation cannot have 0 as a solution. For a reciprocal equation, alpha is a root, then 1 by alpha also should be a root. So 0 cannot be a root, because 0 root means 1 by 0 also should be a root, but 1 by 0 is not defined. So for a reciprocal equation cannot have 0 as a solution.